So in this logarithmic equation, we notice that there are logs on both sides. So when we have logs on both sides, that works a lot like when we had the same bases as the exponents. The log base 3 of this thing is equal to the log of this guy. So if the logs of these two things are equal, that means that these two things must be equal. Okay? The log of this equals the log of that. That means this has to equal that. So x has to be 17 in order for this value to be 14. And that's basically all there is to it. It's kind of like they divide, but not really. They don't divide. We're just making sure that the log of this equals 14. Because the log of one thing has to be that one thing all the time. So here we have log and log, two logs on one side and log, so we have to condense. We're going to have to condense these so that we have one log on both sides. So once again, we're going to use the property that subtraction of logs becomes division of their values. So log base 7 of x minus 4 divided by 5 equals log base 7 of 4. So if this is true, that means that the log of this has to be equal to that. So if these logs base 7 of this equals log base 7 of 4, that means that this x minus 4 over 5, this equation, must be equal to 4. These things have to be the same. So we go about solving this. We'll multiply both sides by the denominator. So x minus 4 will equal 20. And adding 4 to both sides, our x value is 24. Okay, so in order to get it in the form that we want it with one log and one log, you're going to have to do some condensing. So remember those properties of logs. Subtraction becomes division. Addition becomes multiplication. Products become powers so that we can have one log on both sides. Okay, our last one, it looks like we have to condense these ones, and we will have to condense these ones as well. So we still have division or subtraction. Subtraction becomes division. Subtraction becomes division. So this is the log base 5 of x plus 2 over 6. Sorry, that's a 2 equals log base 5 of 2x minus 4 over 10. So once again, this quantity must be equal to that quantity if their logs are also equal. So x plus 2 over 6 must equal 2x plus 4 over 10. These have to be the same values. So what I have here are two rationals that are equal. We solve these by cross multiplying. That's how we solve any equal proportion. So 10 times x plus 2 must equal 6 times 2x minus 4. And then we're going to go about solving this nice equation. So we'll distribute into here, distribute into there. 10x plus 20 equals 12x minus 24. Okay, I'm going to subtract my 10 to this side. 2x. I'm going to add my 24 to that side. 44, and dividing both sides by 2 means that x equals 22. So you might have to do a little bit of condensing in order to get one log on this side equals one log on that side. Okay, one last time. In this case, addition of logs becomes multiplication of their values. So this will be the log base 4 of x minus 3 times x plus 3. So we are multiplying these two things together, and that equals a log base 4 of 7. So that means that this must be equal to 7. So I'm going to distribute here and simplify this. If I simplify that, I get x squared minus 9. Okay, here we get an x squared. This is a positive 3x. This is a negative 3x, and this is a minus 9. So if I simplify x squared plus 3x minus 3x minus 9, I get x squared minus 9. And I can solve this. I add 9 to both sides. Because I have an x squared and no x value, I'm not going to make a quadratic. I'm just going to solve this. So x squared equals 16. Taking the square root of both sides, x equals 4 and a negative 4. Because when you square root things, you get positives and negatives. But because these are logs, we can't take the log of a negative. It's undefined. So we throw out the negative 4, and we get positive 4 as your answer. There's the bell. I guess that means the video is done.